Please make sure you have your copy of the assignment, which is the better antacid, in which we ask the question, which is better, Tums or Gaviscon? Both react with the hydrochloric acid in your stomach to reduce its amount, but they work slightly differently, different active ingredients and different amounts. So yesterday what we did was we started by predicting how much acid would Tums use up in your stomach and how much acid would Gaviscon use in your stomach. Today what we're going to do is find out if that's really the case. So we're going to follow the procedures on part 2. Now what I made up were some solutions of stomach acid, and I put some Tums in there. Each 20 milliliters of solution has 0.15 grams of hydrochloric acid, stomach acid, and then Tums were added to that solution to reduce the amount of the acid by however effective the Tums is. I did the same thing for the Gaviscon. I made the same solution. 20 milliliters has 0.15 grams of acid in it. Put in some Gaviscon and let it use up some of the acid. We'll find out how much acid remains in the samples that we titrate. So each person is going to need one small white cup and a little pipette and a cup to sample for Tums and a cup to sample for Gaviscon. What we'll do is we'll follow these procedures and take data for Tums titration and for Gaviscon titration. Each person can do their own data collection. So when you look at the procedures, the first thing that you'll need is a small white cup, and we'll fill that halfway with our solution of potassium hydroxide. This is the stuff that we're going to add to the acid to see how much acid there is. The potassium hydroxide solution, each milliliter has 0.010 grams. And we're going to add it 1 milliliter at a time using the little squeezy pipette. Draw the liquid right up to the black line for each 1 milliliter that you want to measure. And then you're also going to put some of the Tums solution into a cup. You'll need 20 milliliters of the Tums solution. To measure that, use a 20 milliliter pipette. It says 20 milliliters on it, and there's an arrow that points to the 20 milliliter mark. Draw the liquid up using the syringe until you get to that arrow, and then put it into your cup. You also need the phenolphthalein color change indicator. This is the one that tells us when you've used up all of the acid in the mixture. 5 drops. 1, 2, 3, 4, 5. Okay, when you're ready to do the titration, what you'll do is you'll take the cup of potassium hydroxide and the little squeezy pipette and draw 1 milliliter, so up to the black line, and put it into the cup and swirl it around. What you're looking for is a pink color change that stays permanent. I don't see a pink color change here, so I'm going to add the second milliliter. So 2. I'm going to keep track of how many I add. 2. And so on. I'll count each milliliter until I get a pink color change that doesn't shake out. So this is going to be 3. And I'll keep going until it turns pink and stays pink. Let me skip ahead and show you what that's going to look like. Okay, I've been adding 1 milliliter of my potassium hydroxide solution at a time, and I think I'm getting pretty close to the end point because it's starting to turn pink. So I'm going to add another one here. I see the pink color, but I'm going to swirl it and the pink color goes away. What I'm looking for is which milliliter do I add that makes it turn pink and stay pink. So there's pink, and there we go. So that's what I want to count, how many milliliters I had to add for that to happen, and then I'll record that on my data table for the Tums titration, and then I'm going to repeat all the same steps again for the Gaviscon sample. So make sure when you're all done that you pour out the cups and you can throw them away, and the little squeezy pipettes can go back in the cup where they came from.